for letting me observe your class.
Absolutely.
And it was awesome to get to do and to learn from another teacher and see how you do things and that sort of thing. So just for a little background, this class I'm taking is teacher leadership, and I was a little, like, when I started in this class, I was like, but I still have so much to learn. And the cool thing about it is, like, it talks about, you know, teachers being a resource for each other, you know, so instead of having an administrator come in or learning it from some professional development thing, it's just like, you know, the back and forth, like learning from and then picking up ideas from other people, which I think is really cool. So one thing it talks about like a community of practice, you know, and so just having other people that are there with you, you know, and being able to just learn from and with other people. So anyway, so I observed your AP chemistry, right? Was it AP chemistry?
Pre-AP chemistry.
Pre-AP chemistry, that's right. Okay. And I need to change that on the form. And so the lesson was about the properties of water, specifically polarity, and then reviewing notes from the previous day where they had done their doodle notes, right?
Yes, because
Is that what you
I ended up having to be absent. So they copied the notes while I was gone, and then we went over them with an activity. Yeah.
Right.
Doodle notes, yes.
Yes.
Some people call them scribble notes. There's a couple other names for them, but they're fun.
Yeah. So just how did you feel about the lesson that day? Like, what were your overall takeaways from it?
It went pretty well. Which class period do you remember? Was it sixth? Okay. I was trying to remember because I don't always get to the same places. I feel like it went overall pretty good. Normally I don't have them copy it all before we do like portions at a time and talk about them as we move through. So that was a little deviation of what I normally would have done with it. But I think they got the point, they got the picture, and the little activity with the penny and the water droplets kind of got them interested, and then we talked about the whys, and so it kind of gave them the why for all of that. And I thought that was kind of a good, usually I do the penny thing as a whole lab where they're doing testing and they're doing, you know, multiple trials and they have to average them and do all this other stuff. But I think this worked a whole lot better because it brought them in and then we could talk about it and then we moved on because we don't cover all the properties of water in chemistry. Polarity and universal solvent are the most important.
Right. And that's one thing I learned from watching that is, you know, I think I would have been tempted to make it like this whole, and you had like, I mean, it probably took what, 5-10 minutes?
Yes.
And it was such a good activity for them to, you know, hands-on, they got to see how it worked. They had, you were having them guess beforehand, and then they got to see, you know, how that, what the reality was, which was really cool. And so that's something I picked up is like, you know, you can do some of those things and it doesn't have to be full blown. It can be just like a few minutes. So that was really cool. So on this checklist, I noticed that the materials were easily accessible for the students. The technology that was used was the smartboard in there. And I was wondering, and I was kind of looking around your classroom, do you have so if when you're doing labs and you want everyone to be able to see what you're doing close up, do you have anything like that?
I don't. Most of the time they're doing their own thing at their own pace, and so if we're doing a full-blown lab, I move around the room and make sure everybody is getting pieces, and like if they seem to be lost or off task, I'll ask them questions to get them back to where they need to be.
Yeah.
But I do have a microscope now that I can use, and it's got a digital screen, and so if I really need them to see something specific and I want to make sure that's what they're seeing, I can use that.
Right.
But for the chemistry aspect of it, it's pretty much everybody does their things.
Right.
I've had a document camera in the past, I just didn't utilize it very much.
Yeah, right. And I didn't know if, you know, if there was something different for using with labs. I know, like, for my daughter, for Abby, when they do culinary, it's almost like it has a camera tilted down at the teacher table, and then it just goes on all the screens and stuff.
I've seen that. We have those at the Region Center, and those are really cool. We have these calculators where you can plug probes into them, and then you could like pull the data and put it up on your screen. But they've kind of gone away from that, and more we plug probes into Chromebooks, and we can do it that way. But there's not really a way to pull the data from each Chromebook and put it up on the screen. If I wanted people to look at somebody's graph, I just call them over and say, hey,
Right.
come look at this, or screenshot that for me, and then I'll put it up the next day.
Cool. Okay, but you did use technology in the smart board and drawing the polarity and that sort of thing. The routines and procedures seemed like they were well in place. The girls knew where to go get things when they needed them and that sort of thing. And it was a respectful environment. In fact, they were trying to help each other out with getting the smart questions. So that was good.
The smart choices and good questions board is super important for that class.
Yes.
They love it.
I loved it too. And so the types of instruction that I noticed were whole group, guided practice, and independent practice. But I noticed they are at tables, so I'm going to guess that a lot of times it's collaborative.
Most of the time.
Yeah. And so I really wanted to commend you on how clear your oral instructions were for the experiment. You know, I think that you did a really great job of kind of anticipating what might be the problem, you know, like, and with the pipettes and that sort of thing, and telling them, you know, like when they should use those and when they should not use those and that sort of thing. So you did a great job there. And using the expected academic language throughout, like when you were talking afterwards about variables and controlled portions of the experiment, I thought it was great that you were using those terms so that they could see that what they were doing applies to, you know, this is why we call it this. So I thought that was great. And then one question I had, like they got to choose the heads or tails, you know, and I know you were trying to keep the activity short, but I just started wondering, like, if that would have been an opportunity for a higher order thinking, you know, like on why would you want to choose one over the other? What is it? Would it matter? Would it affect the experiment?
Normally because I was out the day before, I didn't I wanted to do 2 days for it. We would have done a little bit more and let them pick and then compare them. And a lot of times if I have the time, I don't tell them heads or tails. We come up at the end, I'm like, well, what did you keep constant? And then they're like, okay, well, what did you use heads? What did you use tails? I was like, can I compare your data? And they're like, oh, you can't, because it's not the same.
Right.
But with the shortened amount of time this time, I had to keep it as close, and
Yeah.
that way we can talk more about control, because that's one thing we were able to control.
Right.
And sometimes we don't talk about that as much, but we were able to do it.
Yeah. And I can see how you would be able to refer back to this. Like, remember when we did this? These were our controlled things, and then they did it, so they have that in their mind. So that was great. And then being able to see how those really work in the real world. It wasn't just on the notes. So then as far as the teacher moves that I saw modeling, or I saw higher order questions with your smart question system, where they go over and get a sticker or candy when they have a smart question. And then the differentiation, I noticed that when they were figuring the average, that you directed that if they wanted a calculator, they could go get a calculator. So that was a form of differentiation. And they knew right where to go to get that, so I could tell you use that frequently or regularly. And then providing academic feedback. At the end of class, you were passing back papers that you had graded. So I was like, that's academic feedback. So, so I noticed you were redirecting groups with keeping the drops consistent and remembering to use the head sign of the coin, like as you were going around and seeing, you know, maybe seeing where somebody wasn't doing what they were supposed to do or what they were meant to do in that experiment. And that the materials were readily accessible and the activity was tied to the notes. So, you know, they were using previous learning for what they were doing. And then the polarity, where you drew the examples and that sort of thing, and they used the backside of their notes. So the glows I saw, and I've talked about a lot of them, but the incentivizing the smart questions. I love that when one of the students caught your mistake, that you let her go up to the board for catching your mistake. I think it's really important that they see that we make mistakes and we own up to them. Yeah. So, and the expectations were clear when you were when you were using the tools, and I realized that it was just water this time, but I love that you're consistent with that. You know, like, don't pick up the tools and start using the tools until you're supposed to, because then when you're not just using water.
Yes.
Yeah.
And I was really surprised that none of them asked if they should have goggles on. A lot of the times I'll get that question, well, do I have to wear goggles this time and stuff like that, and nobody even asked that this time, so.
Yeah.
That's kind of bummer.
That's a good point, but, yeah, but I recognize why you were doing that, because even though it's just water and pennies, you have to set that precedent. And then, the grows, I put, you know, there might have been some opportunity for higher order thinking and collaboration and student driven learning. I know that those are probably things you usually do in your classroom, so I realized the intent here, so I didn't, you wanted to keep it short, but it served its purpose. Could they compare each other's methods, maybe? Like, could they watch each other and see if the person across from them is using the same size drops as they are, or, you know, could they analyze why there was such a variation in their numbers? And again, that might just be a time thing. And then could you have a system to keep, one person, I can't remember, I don't know the names, but she was like, well, what if we did this, or we should try this? And I wondered if you've done such a great job of establishing, like, those are good questions. Like, if you could almost have, like, just a log of you know, the what ifs or should we tries, and just kind of keep track of them.
That's a good idea. In some of my other classes, I've had like a running Google sheet where, like, if they have a question I can't answer during class or something, or there's somebody who wants to go deeper into something, then they can go type that in there, and when I have time, I run through those. I don't have that for this year. It's usually with my AP Chemistry kids that I have that. And sometimes with forensics, if they want to study specific cases, they'll go in and add that kind of stuff. But.
And, you know, I recognize sometimes kids are doing that because it's just, like, can we go off this way?
Yes.
But I love the way, since it's a science class, and really any class, that you are promoting questions and how important questions are. So that was just an idea that I was thinking about, but we've already had that idea.
It reminds me that I haven't done it this year.
And then one that I always struggle with, and so I put to make sure to provide wait time on questions.
Yes.
And that might help with, you know, that group that is, they're really wanting the smart question thing. So maybe you can say, I'm not even gonna listen to anybody's for 30 seconds, or that's a long time actually, but 10 seconds, you know, just to give everybody a chance to
think it through. Yeah.
I'm terrible at wait time.
I am terrible at wait time. I try. And I don't like popsicle sticks because I lose them, and then some kid never gets called on.
Right.
I've done the spinner board before, but then I have to have two things running at the same time. And
Yeah. Wait time's hard.
Yes.
But I guess a question that I had at the end is, if you were going to do this lesson again, would you do anything differently?
I kind of like a mix of what I've done in the past and what I did this time. I liked that it was short and sweet, and we were able to move on a little bit quicker. But like you mentioned, like the other questions, like being able to test both sides, I missed them getting the chance to do that. So I would probably want to maybe do it at the beginning, talk about all the things that we have to with water properties, and then maybe let them design their own experiment or test it in some ways, so that we still have a 2-day process with it, and they get to test out those other theories that they have. Because they're like, well, what would have happened with tails? But I don't even think the bumps would have mattered, and that kind of stuff. I missed that part of it, and not giving them a, hey, you have to do this, but let them design their own.
Right.
To test out their own theories.
Yeah, and that would be great, to have their own buy-in on it. Do you think that there would be a way that you could increase the rigor?
This one is pretty low rigor one, because we don't have to have a lot of knowledge. For water properties, it's really just polarity and knowing that's a universal solvent. So this one's not a really high rigor portion anyway. It's a quick move on type of thing. We deal with it more. It's kind of like a precursor to solutions and dilutions and stuff that we go into next. So I don't really think I would increase this rigor because they don't have to know a whole lot.
Right.
So
Okay. But it does lead to the
it
next
does
thing
lead,
down the road.
yeah. It's
Okay.
like it's a base for what we're doing next.
And then, let's see, if you were going to celebrate one thing with this lesson, like one thing that you just feel like went really well, and it doesn't have to be with sixth period, the one that I.
Yeah. Just their general understanding. They took their test today over water properties and limiting reactants, which is something else we were doing. And I think I only had 3 out of my 3 classes that didn't get a 90 or 100 on it.
Wow.
So I mean, they knocked this one out of the park. So I'm guessing that the way it was done this time really converted easily into knowledge.
So now you've got data to back up that what you did work.
Yeah, this time. Yep.
Yeah. Okay, and so what would be your next steps for? I mean, obviously you know where that led this year. So and you said next year you might kind of do like a hybrid of.
Yes, maybe send out the doodle sheet the day before and let them copy down the words. Because the doodle sheets are awesome, but they really like to color, which is a good and a bad thing because some kids it helps them focus a lot better, and so that's one reason why I do them. But get that part where they're doing it, and then we can talk about it, do the activity in class, and then the next day just convert it into, okay, design this yourself. What are you going to do so that you can teach me something about surface tension and cohesion?
Just out of curiosity, do you think that, because you've done both kinds of notes, do you think that they take better quality notes with doodle notes?
I think that the doodle notes can not really entertain, but it keeps the buy-ins a little better because a lot of students don't know how to do notes. And I use different versions of the doodle. Some have, like this one didn't have very many holes on it at all. Like most of it was already filled in, and it was a lot about the pictures and the drawings and stuff. Some of the doodle notes that I've used, they have to write more, and some of the people that I've gotten them from, they're scaffold, and so sometimes they have almost everything there with just a few words out, and then the next one has most of the stuff, and then some are just completely blank.
Right.
And so those kids who really need to write, you could print out, you could have differentiation and just let them pick which style they want to work with. So I think that might be an interesting direction to go, give them a little more creativity over it. But the feedback I have from the kids, they love doodle notes. Like you try to tell them we're going to take notes today, and they're like, oh. But then you pull out the doodle notes and they're like, oh, okay, I can do this. They don't feel overwhelmed by figuring out how to organize it themselves and all that kind of stuff.
Do you feel like they keep up with it better because they have?
I've seen them pull them out.
Yeah.
So I know they haven't been lost. And sometimes they pull them out because they didn't finish coloring something, and so they're looking at it as they're coloring and like, oh yeah, I forgot about that. Or it brings up conversations between them. I'm like,
You're like,
okay.
teacher when you're
Yes.
looking at stuff.
You're going back to your notes.
Is there anything that that you think I didn't mention that you would like to talk about with that lesson?
I don't think so. I think you hit all the points.
Thank you so much for letting me watch your class and learn from you. All right. Sorry that took so long.
No,
I
you're
got
good.
sidetracked about doodle notes.